Hello everyone, welcome back to my channel Science Sutra. In this video, we are discussing about the image formation, how the images are formed when we are using the lenses. Okay, in our previous videos, we have discussed how the image will be formed if we are using the mirrors, right? In the same way, we have to learn how the image will be formed by using the lenses. Okay, in order to study the image formation, how the images will be formed by using the lenses, we can do an activity. Okay, but in my videos, I'm not doing the activity because I'm not having the convex lens stand, everything. For doing that activity, we require the convex as well as concave lenses. Okay, and we need to have the lens stand. Okay, source of light, for example candle. Okay, and we need to place a screen, okay, that we can take as a white sheet of paper. Okay, these are the things which we require to do this activity. Before conducting this activity, first what we need to find is we need to find the focal length of the convex lens or concave lens. Whatever lenses we are using, we need to find the focal length. How we can find the focal length of that? See, if we are taking the lens here and this is the screen, okay, and the source of light if we take here. If we are moving this convex lens in such a way that we have to get a bright spot of the image here. Okay, if we are getting the bright spot of the image, if we are placing the lens here, then whatever the distance that we are measuring between the lens and the screen, that gives the focal length. Okay, that focal length we need to take. For example, if I take that as 10 centimeter, that we need to mark down. Then what we have to do? We have to draw 5 parallel lines. Okay, how many lines we have to draw? We have to draw 5 parallel lines. Okay, on the table wherever we are doing this activity, we have to draw the 5 parallel lines. The distance between each line, it should be 10 centimeter. Why I am taking 10 centimeter? It is the focal length, correct? This focal length value we have to take for the distance between each line, and whatever the lens stand that we are taking, we have to place here. Okay, lens stand. Okay, this is the convex lens we are taking. This is the lens stand. Okay, next what we have to do? We have to take the screen which is placed somewhere here. Okay, and next what we have to take? We have to consider the source of light somewhere here. Okay, this is the source of light. And what we have to do? We have to mark the focal length. Like if we take the focal length here, it should be around 10 centimeter f1, and the twice of that will be 2f1. Okay, that will be equal to c1. And here we have to mark that as f2, and twice of that will be 2f2. These points we have to mark on the line, central line. Okay, why we are taking this central line? This coincides with the optic center of the lens. This is the lens point, center point of the lens, and this point will be coincide with this ray, and whatever the ray that is passing through the optic center, it will comes out without any deviation, correct? So this is the pattern of the activity which we have to do, and this is the source of light. If we consider the source of light at infinity, if we consider this source of light should always be placed towards the left side. We should not take towards the right side, it should be taken towards the left side. If I take this source of light somewhere at the infinity point, okay, and by moving this lens stand we have to get the image on the screen, and we have to note down the nature and the size of the image, whether it is showing a maximum or whether it is showing a diminished image. Like that we have to mark down. How we have to mark down? See, this is where we have taken the source of light at infinity. If we are considering the rays that is coming from infinite point, that is first case. And if we take the second case, we have to place this source of light somewhere here. If you see this table 10.4 which they have given in your textbook, you can see, right? You will get to know where we have to place the source of light. Correct? Here the object is nothing but the light which we are taking. Okay. And beyond 2f1, we have to take second case. How we have to consider? We have to consider this candle somewhere near to 2f1 we have to take. And how the image will be, we have to note down. Next, where we have to place? We have to place at 2f1. If we place at 2f1, how the image will look like, that we have to note down. In this way, we can do this activity. By doing this activity, what you will get to know? You will get to know how the images will be formed using the lens. This is one method where you can study. Okay, this is one method where we can study the image formation by lenses. Correct? And one more method is there which is very easy, which we can do without doing any activity, which we can write down actually, which we can draw. Okay, if we draw only, we will get to know how the image will look like. Correct? When I was discussing about the mirrors, I discussed how the reflected or how the refracted ray will look like. In that case, I was explaining about the reflected ray, and here in the lenses, we need to talk about the refracted ray. Correct? So, if I take, there are 4 cases. Cases in the sense, if we want to draw the ray diagram for the lenses, we have to consider at least any 2 rays. Correct? See, if the ray is passing through the focus, how it get refracted, that we need to study, right? And if the ray is traveling parallel to the principal axis, how it will get refracted, that we need to study. By studying that, what we will get to know? We have to take that 2 rays in order to study the image formation. So, before studying the image formation, we need to know some basics, right? See, for that, we have to consider a convex lens. I will consider a convex lens. Okay. For that, we know it will be having the optic center O, correct? And it is having the focus f1. 2f1 is nothing but c1. Okay. And here f2, this is 2f2, or you will take c2. And the light and the line that is passing through all these points, you will call that as principal axis. Correct? And if I consider the ray that is traveling parallel to the principal axis, if it is traveling parallel to the principal axis, after refraction, how it will get refracted, or how the direction of the light ray will be? It will move towards the focus. It will pass towards the focus. It will pass through f2. This is first case. Okay. If we want to write the image formation using lenses, we have to consider any 2 rays. Correct? For that, we are studying this. Okay. For that, we are studying. If I draw, or if I take second case. What is the second case? If I take the convex lens here, same thing you can write down. Okay. This is the optic center. This is f1. This is 2f2. f2. Sorry, this is 2f1. f2. 2f2. And if I consider the ray that is passing through the focus, Okay. If I consider the ray that is passing through the focus, okay, that is passing through the focus and it is made to fall on the lens. So that after refraction, how it will be? The direction of that ray will be parallel to the principal axis. All these cases we have studied in the case of mirrors. Same thing we have to write down for lenses also. This too is the case for convex. If we are talking about a concave lens, same thing we have to write down. Okay. This is concave, correct? My lines are not, I'm not getting or I'm not drawing correctly, right? 1 minute. The straight line passing through this, and here we have to mark as F1, F1, 2, F1, okay, F2, 2, F2, and this is O, correct? And if we consider the ray that is made to fall on the lens parallel to the principal axis, how it will undergo refraction? As we know, it will diverges the ray in this direction, and if we project back this ray, okay, it is meeting with the point F1. That means after divergence of this ray, if we extend back, it will meet at the point F1. This is how the case you will see in concave lens. Okay, same thing if we take same thing we have to draw. Okay, for convex, if I take this as F1, this as 2F1, F2, 2F2, okay, and this is point O. If I consider the ray if I consider the ray in this way, like, okay, and if I extend back, it should meet at F2. After refraction, how it will be? It will after refraction, it will pass in this direction, or it will move in this direction parallel to the principal axis. These are the two cases that we will see in convex and concave. One more case is there. What is that means? We have to consider the convex lens, and what we have to write? We have to write the principal axis, correct? And we have to mark here. This is F1, 2F1, F2, 2F2. And as we know, if a ray is made or if a ray is passing through the optic center, how it will go? It will go without any deviation like this, correct? This is the case of convex lens. What about the concave lens? And we had to write down or we had to mark here, correct? This is F1, this is F2, sorry, 2F1, F2, 2F2. And what about this? Optic center, correct? So if I make the ray that is passing through the optic center, it will undergo refraction without any deviation. It will not undergo any refraction, just it passes through the optic center without any deviation. Okay, all the three cases which I have discussed both in concave and convex lens, these cases we had to use, any two cases we had to use to draw the image formation in the case of concave or convex lens. Okay, for that, first case we have to consider. What is the first case? If we see the first case where we have to place the object, where we have to place the object, we have to place the object. Yes, if we see this table, what is the first position that we have to take? We have to take the position of the object to be at infinity. Okay, for that we have to consider the parallel beam of rays. See, first before that we have to draw the convex lens, and what else we have to draw? We have to draw the principal axis that is passing through the optic center. Correct? Here we have to consider a straight line that is passing through the optic center, and we have to mark the points here, that is F1 to F1, or else you can take C1, F2 to F2, that is C2. See, since we are taking the object to be at infinity, we have to consider the parallel beam of ray. For that we have to consider any two kinds of rays you can take. In this case I have taken both the rays to be parallel to the principal axis. So after refraction, what it will do? It will make the ray to converge at a point, okay, that is F2. So if we are talking about the nature of the image, okay, the image is formed something here. The image point is F2. So we can talk here the image is formed at the focus F2, correct? And how the nature, how the size of the image it will be? It will be highly diminished image, point-sized image you will get if we are taking the position of the object to be at infinity. And what about the nature? We consider the object to be beyond 2f1, how the image will look like. Okay, that we need to draw, correct? So how we can draw means we have to consider the convex lens and a straight line passing through the convex lens. So we had to mark, this is F1, F1, this is 2F1, F2, 2F2, and this is optic center O, correct? And we have to consider the object to be somewhere here. So I will take this as A, and we have to use any two rays. So I will take one ray will be parallel to the principal axis. Okay, after refraction, how it will be? It may or it passes through F2, correct? And one more ray I will consider. One more ray which I will consider is okay, which I will consider is the ray that is passing through the optic center. Okay, the ray that is passing through the optic center. Okay, where these two rays are meeting, it is meeting somewhere here, correct? It is meeting, I will use some other color. It is meeting here, so the image is formed here. Okay, if we look at the image, it is a diminished image, size of the image is diminished, and it is real as well as inverted. It is real and inverted image we will get. The position of the image, it is between F2 and 2F2. If you see this table, you will get to know, right? when the object is beyond 2f1, it is between f2 and 2f2 and the size will be diminished and it is real and inverted image. Like this you can draw for all the cases. If you want, you can draw for 2f1 also. 2f1, okay, this is convex lens I have to take. This is 2f1, 2f1, f2, 2f2 we have to take, correct? And one more we have to consider any two rays, correct? One ray I will take. First we have to take the position of the object. Where we have to take? We have to take at 2f1. If the object is at 2f1 AB, how the image will be? Okay, that we need to find out. For that, we have to consider any two rays. Okay. For that, I will take a ray that is passing through f1 and it is falling here. After refraction, it passes in this direction. Okay. Passes in this direction. And one more ray I will consider, that is passing through the optic center. Okay. And these two rays are meeting somewhere here at 2f2. It is meeting at 2f2. Okay. So we can take the image is formed. If you see this table, the image is formed at 2f2. If you are taking the object at 2f1, you are seeing the image at 2f2 and it will be of same size, but the nature of the image will be real and inverted. Real and inverted. Like this, you can draw the ray diagrams. Okay, using ray diagrams, what you are finding actually, you are finding the nature, position, as well as size of the image. Correct? You can either use an activity to do this or to find the image formation. You can also use the ray diagrams to find the image formation. Correct? And this is the case for convex. Now if we study about the concave lens, here there are only two cases where you will get to know the image formation. What are the two cases we have to take? We have to consider the image, the position of the object to be at infinite. First we have to consider the infinite position of the object. Okay. So we have to mark here optic center. This is the optic center, f1, 2f1, okay, f2, 2f2. And what happens if a ray is coming from infinite distance? Okay, it is coming like this. These two rays are falling on this lens. Okay, after refraction, what happens? It passes through f2. Correct? Yeah. What happens in this case of concave lens? We have to see, or we have to do like this, right? We are not doing that. Yeah. After refraction, it will diverge in this direction somewhere here. And what we have to do? We have to bring back. We have to make it to meet at a point that is f1. Correct? So what happens if the rays are coming from infinite position of the object? The image will be formed at f1 and it is highly diminished point sized image, since we are getting the image to be behind the virtual and direct. The image which is formed in the case of a convex lens, concave lens, will be a virtual as well as erect. Erect means whatever the erect in the sense how you can take, it will be same as that of the object. If the object is upside, the image will be formed will also be in upside direction. If the object is downside, the image will be formed also downside, like this. Whatever the object, however the object you have considered, the image formed will be in the same. Okay, image formed will be straight. It will not be an inverted direction. It will be in erect direction. Okay, if we consider the object is between infinity and the optical center O of the lens, you can take at any point. Okay, see, if I take like this, as we know, this is the optic center, correct? Which is the optic center here. This is the optic center, and we have to take, this is f1, 2f1, f2, f2, 2f2, correct? And we have to consider the object between infinity and the optical center O. Okay. So if I take the object to be somewhere here between infinity and the optical center, I will take somewhere here. Okay, I will take somewhere here. The object is placed here. Okay, it is AB. I will take, and one ray I will consider that is falling parallel to the principal axis, and after refraction it will diverge in this direction, and so I need to I need to bring back this ray, extend back this ray, and one more ray that I will consider is the ray that is passing through the optic center. So if I take, it is formed between, the image is formed here, correct? This is A prime and B prime, that is between F1 and O. O is the optical center. The image formed will be diminished. The size of the image is small compared to the size of the object, and it is virtual. It is virtual as well as erect. Why we are getting virtual image? Because it is seen in front of the mirror, correct? If we are seeing the front of the lens, not mirror, lens, if we are seeing the image in front of the lens, we will call that kind of images are called to be virtual. One more point you have to keep in mind, the images, this is very easy to keep in mind. Okay, the images which are getting because of convergence, are called real images. See, whatever the images that we are seeing in the convex lens, that images are called to be real, correct? Same thing, the images which are getting because of divergence are called virtual images. So we are seeing the virtual image in the case of the concave lens. Okay, this is how we can draw the ray diagrams in order to find out the image formation in the case of lenses. Okay, same thing which we have discussed in the case of mirrors also. The same thing we can apply for the lenses. Okay, first we have to draw the basic ray diagrams. Basic thing we have to draw, correct? That three cases we have to consider, and among the three cases, any two cases we have to take to get the images that is formed in convex as well as concave lenses. Okay, this completes this topic about the image formation that we have seen in the case of lenses. Okay, in the next video I will be discussing about the sign convention. It's all about the magnification, the power of the lens, all that things I will discuss in my next video. If you like this video, please like, share and subscribe to my channel Science. Sutra. Thank you.